Hello guys, Luis Soares here. So in today's video, I would like to introduce a very important aspect of Rust's programming language, which is its ownership model. Sometimes, people find it very difficult to understand how it works because it differs from many traditional programming languages. But today, I would like to do a quick intro to allow you to understand the basic foundational ideas behind it. And I'm pretty sure once you understand that, it will be much easier when you are coding and you stumble on some annoying compiler messages that is, you are using a value that was moved here, you cannot do this or you cannot do that. Let's jump right in. So, how does it work? Rust has a different approach for memory management, as I said earlier, in comparison to traditional programming languages. So, what we usually find in, let's say, Java or some other languages, .NET, for instance, is that, you know, you are there creating your code and you are using variables, you are declaring functions, you are calling them, right? And all those operations requires, of course, that you allocate memory. So this memory allocation and deallocation in most traditional languages are done automatically by a mechanism that's called the garbage collector, right? So what garbage collection is essentially is it's a form of automatic memory management that identifies and reclaims memory that's no longer in use by the program. So as I said, it's a automatic mechanism. So the programmer does not need to, of course, it's good if a programmer is, cautious enough and conscious about how he's using memory. But if you declare 100, variables and, you do what you need to do and your method comes to an end, then the garbage collector you take care of, releasing memory for you. Of course, there are the pros and the cons. There are different approaches in how, when this, garbage collection takes place. It can impact performance. There are many different facets to it, but the programming language will automatically clean memory for you. It doesn't happen in Rust, right? Because Rust on the other hand, doesn't use any garbage collector. So it's up to the programmer to, manage the memory life cycle, but it has two very simple, important rules. If you master those two rules, you are good to go. And it's first, every piece of data has a single owner. Very simple concept. Every piece of data has a single owner. And the second rule is when the owner goes out of scope, the data's memory is released. So it continues to be automatically released, but it's important that you know exactly, when you are taking ownership of data, when that owner goes out of scope, and then your variables memory will be released, right? Let's see some code to help us understand it better. So this first example here, it's a very simple one. So here we have two variables, S1 and S2. So S1 is a string content, hello Rust, right? When you declare the second variable here, S2, and says S2 receives the value of S1, S1 will go out of scope. So there is no more S1. There is only S2, who is the owner of the content that was previously, assigned to S1. So in line 5 and 6 here, if you try to use this S1, then on line 5, you see that this line would cause a compile time error because S1 does no longer exists, right? So this is a very important concept. You have a variable. If you assign anything else to that variable, then the previous allocation is no longer usable. And if you try to use that same reference again, Rust will, the compiler will prevent you from doing that. This is the very first concept. The second concept is the borrowing. So here we have again a variable s with this hello sentence. Here I have a function calculate length, which will take a variable and will return its size, right? So here, when this method here on line 5 is calling this calculate length, passing as variable, as a parameter, you notice it's using this reference symbol here, this ampersand, right? If you don't use this ampersand, what will happen is that once you call this calculate length, passing as to it, this method will be the new owner of s, and as we saw in the previous example, you couldn't use it any longer unless the calculate length finishes using it. But the thing is, when you call a method and you pass a variable to it, that method by default becomes the owner of that variable, right? If you don't use that, if you don't want that to happen, then you use borrowing. And how do you use borrowing? By using this upper sand sign. So if you put this upper side symbol right before the variable name, then this variable value will be referenced by the calculate length method. It will be used there, but the method won't be the owner. So those are the two very foundational rules of the Rust's ownership model. If you stick to this concept, it doesn't matter how long your code or how complex your code is, it will come naturally and you just use it. And that's it from my first video. Also, if you liked this video, I have wrote a entire book about Rust ownership, this ownership from basics to real world projects. There are lots of examples, lots of exercise that goes deep into detail on how Rust ownership model works. And there are also 9 different real world project implementation, like an API gateway developed in Rust, a firewall, and some other implementation. So if you like this video, check it out on Amazon. And if you also like this content, I have a blog on Medium. You can go there and you see lots of contents. There are more than 200 articles about Rust, about programming in general, distributed computing, and many other topics. So check it out as well. And if you like this video, click on the like, share it with your network, and see you in the next one. Bye bye.